Have you ever just stopped and wondered how your favorite app, with all of its menus and options and complex choices, is even possible? I mean, it's all built from simple line-by-line instructions. So what's the secret? Well, it's all about learning how to control the flow of those instructions. Let's dive in and see exactly how programs learn to make decisions.
So, at its most basic, a program is kind of like this bus, right? It starts at the very first line of code and just goes. It executes one instruction, then the next, then the one after that, in a perfectly straight, predictable line until it hits the end. Super simple and very, very linear.
Exactly. The real world isn't a single straight road, is it? We have to handle choices, we need to react to different situations, and sometimes we have to do the same thing over and over. A simple one-way program just can't handle that. So, how do we give our bus a GPS?
Well, that one-way road actually has a name. In the world of programming, we call it sequence. It's the most fundamental structure you can have, and it's the default behavior for any code you write. And here's the thing. Pretty much every program you've written so far, the kind that just runs from top to bottom without any detours, has been using sequence. It's the foundation that everything else is built on. But it's time to add some turns to our road.
Okay, let's get to our first big tool for controlling the flow, selection. This is how we start adding forks in the road. It's what allows our program to actually choose a path based on whatever situation it runs into.
Just think about it in your own life, right? Like deciding which pen to buy or picking the fastest route on a map. You look at a condition, like the price or maybe the traffic, and then you act. Selection lets our code do that exact same thing. It's decision-making, plain and simple.
So the key is how we make that choice. A simple if statement is like asking, hey, is the user over 18? If the answer is yes, great, they can vote. If not, the program just moves on. But if else gives you that alternative path. If they are over 18, they vote. Else, we can show a message saying, sorry, you're not eligible yet. It handles both possibilities.
But what about when there are more than two options? I mean, a traffic light isn't a simple yes or no, right? It's got three totally different states, and each one requires a specific action. An if-else statement by itself isn't quite going to cut it here.
And boom, here's the solution. We use if for that first condition. Is the light red? Then we use elif, which literally just means else if, to check the next one. Okay, is the light orange? And finally, else is the perfect catch-all for that last remaining possibility, which in this case has to be green. It's just a really clean, elegant way to handle a whole chain of decisions.
All right, so now our program can make choices. That's a huge step. But what if it needs to do the exact same task over and over and over again? Well, this is where our next control structure, iteration, comes into play. It's all about creating loops.
No, I mean, really stop and think about that for a second. How would you even start to write that code with what we've covered so far? It sounds completely impossible, or at the very least, unbelievably boring and tedious.
You'd have to do this. You'd literally be typing a print statement for every single number. Your fingers would cramp up, your code file would be gigantic, and heaven forbid you needed to change it to 101, you'd have to start all over again. Yeah, this is not the way.
And then there's this, the elegant solution. This tiny little block of code, a while loop, does the exact same thing. It sets a counter to 1, and then it just says, hey, as long as that counter is 5 or less, print its value and add 1 to it. It just repeats that process on its own. And the best part? To make it go to 100,000, you just change that one number 5. That's it. That is the incredible power of iteration.
So that's what loops are all about. They're just for repeating a task. You can almost think of it like the life cycle of a butterfly. It's a process that repeats. As long as some condition is met, the code inside that loop will just keep on running again and again.
Now, a super common partner in crime for loops in Python is the range function. It's this fantastic little shortcut for creating sequences of numbers. You can give it just a stop value to count from 0, or a start and a stop value, or even a step value to count by 2s or 5s, or you could even count backwards. It's incredibly versatile.
Okay, so loops are powerful, but sometimes just running a loop from start to finish isn't quite what you need. What if you're searching for something and you find it right away? Or what if you want to skip over just one specific item in a list? For that level of control, we have even more precise tools. Let's meet break and continue. Think of the break statement as your emergency exit. The second the code hits break, the loop is done. Over, kaput. Continue is different. It's more like a skip button. It says, you know what, let's skip the rest of the work for this one item and just jump right ahead to the next one.
Here's a perfect example of break in action. The loop is supposed to run 10 times, covering the numbers from 1 to 10. But inside, the code is checking if the number is 8. So it prints 1, 2, 3, all the way up to 7. But as soon as the number hits 8, that condition is true, break gets executed, and the entire loop just stops dead in its tracks. It never even gets a chance to print 8, 9, or 10.
Now let's compare that to continue. This loop is set to run 6 times for numbers 1 through 6. When the number is 3, that continue statement tells the loop, hey, skip everything else you were going to do for the number 3 and just continue on to the next number. So the print statement for 3 gets skipped, but the loop keeps right on chugging, giving us an output of 1, 2, 4, 5, and 6.
So we've really covered some ground here. But what's so amazing is that these simple ideas we've just talked about, they are the fundamental building blocks for literally all software.
In the end, it all comes down to these 3 pillars. Every complex program you've ever used is just a clever combination of these concepts. You've got sequence, our default straight road. You've got selection, which lets our bus handle all the forks in the road. And you've got repetition, which acts like a roundabout for any tasks that need to happen over and over again. That's it. That is the secret.
And we'll end on this fantastic quote from Guido van Rossum, the creator of Python. Why this quote? Because in Python, the very structure of these if statements and loops is defined by how you indent your code. That flow of control we've been talking about isn't just some abstract idea. It's visually baked right into the language itself. It forces you to write clear code. So it leaves you with a final thought. How does seeing the structure of a program actually change how you think about solving problems with it?